Hi, I'm Kate, and I am a geophysicist within the ACMA project. Today I want to give a brief introduction to seismic data. Seismic data sets are extremely helpful tools for understanding what is happening below ground. I study the way fluid moves through the ground and what causes it to move in the first place. But since I can't go underground to see what's happening for myself, I rely on tools like seismic data sets to help me understand. All my study sites are at sea, so I need a ship to help me collect data. Behind the ship, we tow an air gun, which generates basically big booms. When you hear something boom, like an explosion, sound radiates out from the source of the explosion in waves. Sound waves, or seismic waves, are generated behind the ship and travel through the water column to reach the seafloor. One important thing about seismic waves is that they can either reflect or refract. They either bounce back or they keep going down underground. And what causes this to happen is basically the density of the material they hit. So take the seafloor. Above the seafloor is water, and below the seafloor is sediment. Water is very different from sediment, which causes seismic waves to reflect. Reflected seismic waves will then travel back through the water column, and we record the returning wave on hydrophones. Hydrophones are basically underwater microphones which listen for any energy returning. But not all of the energy reflects. Some of it continues. The amount of energy which reflects and the amount that continues allows a geophysicist to understand the type of material that caused the reflection. The more different two materials are, the more energy will reflect. And the Earth is basically made up of lots of different layers of different materials. So using seismic data, we can see these material changes without actually being able to visit them and see what is happening for ourselves. But how does this relate to methane? Well, methane is a gas, so it's very different to sediment. That means that when seismic waves encounter gas, a lot of the wave will be reflected, and not so much will continue. This makes an observable feature in seismic data. They're typically called bright spots because they look so much more colorful than the rest of the data. And we can use these bright spots, we can use these indications of subsurface gas to identify how methane might move through the subsurface, but that is a video for another time.